officially the start of part 2, gravity and shit. With me, the terrible teacher. We're gonna get physical with the terrible teacher in part 2, gravity and shit. With me, the terrible physical. Anyway, so we have to. I'm just gonna do something crazy, okay? Wait. This is kind of fun. All right. So do you know what this is? Of course you don't. That's why I'm here. The terrible teacher in part 2, gravity and shit. I'm just gonna write this out, okay? Force of gravity, Fg. That's what Fg means. Force of gravity is equal to your mass times 10, 9.8. 9.8. I think that's right. Yeah, that's right. Okay, so are you ready? Are you ready for this? Are you ready for this? Okay, so if something weighs 10 kilograms, like a book, okay, book weighing 10 kilograms is pulled down by gravity at mass times 9.8, which is 98 newtons per, wait a sec. I don't know, 9.8 newtons. 1 newton is enough to give a 1 kilogram object 1 meter per second of push. So if you give 1 newton of force onto a little box on the ground that weighs 1 kilogram, it will then move 1 meter per second, neglecting friction, because friction will mess everything up. So if you do this on ice, then it should move at 1 meter per second. Anyway, that's what a newton is. So this will make it fall fast, but it's dang it! I thought I was on a roll with this. This is good. This is getting freaky. I'll go get my fucking laptop from my fucking car. Oh, watch out, Dad. Oh, I'm gonna step on my dog. Okay, follow me. Come on an adventure with me. Into my car, you will see. We'll learn about gravity and shit. But mostly shit. I'm in my car looking for it. Hello. Found my laptop. I'm gonna bring it up. Here I go. This is the most stuff I do on my day off ever. I hate moving. I weigh 600 pounds. It's a killer on my back. Look at climbing upstairs and shit. Watch out, dog. Get out of here. It's fucking cold in my room too. Okay. Bust his butt. I forgot the fucking mouse. Okay. Watch out, dog. Going back fucking down. Get the fucking mouse. Swear to God, dude. I can't do this. This is the path I've chosen. Oh, God damn it. Son of a bitch. The fucking piece of shit, I swear to God. Okay, I got it. I still have to deal with the fucking shit-ass laptop keyboard. God, actually, I was pretending to be exhausted, but I think I actually am. Okay. Here I am. Okay. Just give me a sec. Now I have to go pee. I'll be right back. Let me set this to the side and move all this fucking junk food. Peanuts and... Well, that's not very junky. Peanuts and... What? What are you doing? Stop it! I don't need help. What are you fucking trying to say? I swear to God. I'll fuck you up. Okay, part 2. Actually, we're just gonna rename it to part something else. Okay, welcome back to part 2. I don't know what the fuck is going on. Let's go back to sizes of things, alright? Since I can't make this go back to part 1, we're just gonna leave it at part 2. But basically, this is still part 1. Sizes of shit. Size is a shit. Size is a shit. All right. So Eratosthenes, you got 254,000 stadia. Nice job. The current best guess is 249,000 stadia. So good job, Eratosthenes. Moving on to Aristarchus. What the heck did Aristarchus do? He did the size of the moon, plus some distances to like the moon and the sun or something like that. Okay, all right. So Aristarchus, great guy. Oh, that's a good circle, but it's really tiny. Well, whatever. There's the Earth. That might be close to size, scale. However, the moon would actually be more like out here. Or maybe out here. Something like way over there. But anyway, it's not this close. Anyway, during a solar eclipse, which is when the sun is way over here, the shadow that the moon casts on the Earth, and that's when you can't see the moon and it's all red. Right here, the shadow that this makes is 100 miles. Now, on a lunar eclipse, that's when we block out the moon. And yeah, our shadow tapers like this a little bit because the sun is so big. So our shadow doesn't go forever. Anyway, when the moon is in it, our shadow is about 2.5 times as big as the moon. 2.5 times as big as the moon. All right, so I did something really freaky in my notes. All I wrote here, I can't do this anymore. The collective tapering sizes is about 3.5 times the size of the moon. I don't know where I got that or what the fuck that means, but get this shit. Right after that, I also said making Earth the same size. What does that mean? I don't know what that means. Okay, so the moon, I guess the size of the moon shadow, 100 miles. I guess 100 miles is 1 times the size of the Earth. What is this? Where did I get this? This is bullshit. Anyway, I did the math. It checks out. So as we know, 24,900 miles is circumference of the Earth. And we're trying to find the circumference of the moon right now. So, because I have this, wherever the fuck I got it, I'm sorry, guys, just multiply that by 3.5. Turns out you get, you divide it. Divide it. You get 7,000, which is 7,000 miles, which is extremely accurate for the time, but the actual value turns out to be more like 3.7 right here. And that is really close. So that's what I got in my calculator, and this is what Google gave me right here. 6,783 miles. So I guess that's nice. I don't know where I got this. If somebody would actually tell me, that'd be nice. Now that we have the moon size, we can find out how far away it is. All you need is a penny. You can do this right now because I've just given you... Here, wait. Fine. If you have a penny, and then here's the moon. Okay, wait. Okay, let me do this. If you're standing on Earth with your little eye, a big eye. Okay, that's kind of weird, but... And then you have a penny. And then you have measuring tape from your eye to the penny. Moon is directly away. Then, because you know the circumference of the penny and the moon, and you know this distance, you can therefore find out this distance. How does that work? I forget. Diameter of the penny divided by the distance of the penny is equal to the diameter of the moon divided by the distance of the moon. So, no, let's do it in feet. So let's do one foot. So, how big is a penny? 0.75 inches. Okay, then let's do inches. 12, 0.75. I'm a retard. Equal to, we know the diameter, because we know this. We have to divide that by pi or pi squared. I forget. But you can get the diameter of something with the circumference. Right? Let's do this times pi. What the fuck am I doing? If you know the circumference of something, you divide it by pi. I didn't know that. And then, okay, hang on, let me get organized. Okay, so we're solving for D here. 6729 divided by 3.14 is 2143. And according to over here, that's pretty close because we're going off of this, not the actual circumference of the moon. Why are we doing that? Because this is what these guys got. That's why I'm doing that. So now we have diameter. So we'll come back over here. 2143. Oh, we have to do in shit. That's miles. We have to do in inches. Okay. 0.75 inches in miles. Okay, it's really tiny. Fuck. Okay, actually, let's go the other way then. It's gonna be a stupid number. This is gonna be dumb. It's gonna be worth it, though. 2143. God. Isn't that's scientific equation, so 1.3 times 10 to the 8th. I think that's how that works. So you can find out the distance by this. Somehow. It works. So you have the diameter. If you have the diameter and you have everything else also, then you can find the distance, which is 238,000. Isn't that nice? So that's what Aristarchus did. Aristarchus. He did one other thing with the sun. Okay, because we know the distance to the moon, we can find out how far away the sun is. That's pretty cool, right? We have to use geometry. I mean, trigonometry? We have to use... No, I think just geometry. Anyway. No, yeah, Oh, fuck it. Here's the sun. Really big, as you can see. With his glasses. There's the sun. He looks fucking stupid. Okay. So if the moon is half full, that means the light is only on one half. So if the moon is half full, then we know exactly that it will make a 90-degree angle right here. And we know this distance, and we know that angle. So using trigonometry, we can find out this angle, and then therefore this distance. And I don't know how to do it. But basically, this angle right here, which looks like it's pretty small already, it's actually... What are you doing? This angle right here is actually 89.8 degrees, making the sun extremely far away and making Aristarchus like, I don't think that's right. The sun can't be that far away because nobody really knew that the sun was that huge back then. So he basically thought it was wrong. And I guess he quit there. I don't know. That's the last thing I've heard of him. Now for fun times, I guess that's in a part 2, but now is bonus stuff, which is just fun. I think miles? 2, 7, 1, 2, 3, 4, 5, 6, 7. Comma, comma. 12 million? What the fuck? What is this? Aha! Okay, so that's what this was going for. So not miles, it's actually in meters. All the stuff is in meters. I forgot an easy way to do this is every 3 powers up there is like, it goes up from 1,000. Here's 1,000, there's 3. 1,000,000, there's another 3. Next one is 9, which is billion. And one after that is trillion, then quadrillion, then quintillion, then sextillion, septillion, octillion, nonillion, decillion. I know all this because I play video games. I mean, I know all this off the top of my head because I play video games. This is 3.7 times size of moon. 30 Earths fit between the Earth and the moon. That times 30. We can do that. 12 million times 30. So 381 million meters to the moon. Distance, moon, 381 million. Pretty close. So 30 Earths fit between the Earth and the moon, which is pretty cool. But now we're about to get crazy. So the moon is only 3.5 times 10 to the 6. So it's actually like 10 times less. Okay, it's actually 3.7 times less. So that's written as 12,700,000. This is written as 3,500,000. And you can be sure because you just start over here and you go over 6. Or I guess you start here and you go over 6. 1, 2, 3, 4, 5, 6. So it all checks out. That is about 3.7 times. Now the sun, fun time. It's 1.4 times 10 to the 9 power. So I'm going to write this out, and then I'm going to tell you how big it is compared to the Earth-Moon distance. This is written as 1. I think there's a comma here. Whatever. Yeah, there should be. 4, 0, 0, 0, 0, 0, 0, 0, 0. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. What? Get out of here. Okay. So that's 1.4 billion meters divided by God, 12,700. 1, 2, 3. Okay, so the sun is 110 times bigger than Earth. It is 3.7. It is 3.7 times bigger than the Earth-Moon distance. 3.7 times the Earth-Moon distance, which was 381 million. So let's do 381, 123 times 3.7. That's kind of weird that 3.7, well, whatever. Okay, let's check that out. Distance, sun, meters. Yeah, that's pretty close. Billion. No, that's not right. Looks like I wrote down the wrong value because that distance is not at all. Oh my god, dude. 149 billion? I only got 1 billion. That's crazy. So, I don't know. Let's just like do this times 10 twice. So, hey, pretty close. I was 100 times short, but all right. So, that's incorrect. I don't know where I got that. So, I guess I could do I can tell you actually. 149.6. Oh my god. 6, 1, 2, 3, do. Okay, 149 billion divided by, I'm going to do this wrong, aren't I? 381 million. 392 times as big. 392 times as big as that. Holy ass. What are you doing? I swear to God, dude. 92. So that's huge. God. Okay, so that kind of fell apart somewhere along here. It fell apart. Anyway, okay, I guess that's the end of part 2. That took forever, geez. But finally, we're done with sizes. So tomorrow, kids, we'll move on to better things with better stuff and better math. Actually, next episode, we'll talk about... Oh, wait, let me check this off. Next, in part 3, part 3 should be really short. We'll talk about scientific terminology. So look forward to that.